Day 485 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 37, Sudoku solver. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Write a program to solve a Sudoku puzzle by filling the empty cells. A Sudoku solution must satisfy all of the following rules. Each of the digits 1 through 9 must occur exactly once in each row. Each of the digits 1 through 9 must occur exactly once in each column. Each of the digits 1 through 9 must occur exactly once in each of the 3 by 3 sub boxes of the grid. The dot character indicates empty cells. All right, y'all. So that sounds simple enough, but let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So if you're familiar with Sudoku, it's a math game that is played in each column, such as this column right here, for example, should have all of the numbers 1 through 9. So each column, all of these columns should have numbers 1 through 9. Then also each row should also have should have the numbers 1 through 9. So this row should have numbers 1 through 9. This row should have numbers 1 through 9. This row should have numbers 1 through 9, and so on and so on, all the way down here. And then each 3 by 3 grid or sub box right here, you can see that they have the sub boxes outlined in bold. They must also contain the numbers 1 through 9. So it should have 1 through 9 in all of these boxes right here. 1 through 9 should be in all of these boxes right here, and same with this box and all of these boxes. Every 3 by 3 square grid you see should also contain all of the numbers 1 through 9. And then each period or each dot, that just represents a an empty cell. So as you can see in our input board, that equals an array of equals a 2D array of strings. And as you can see, each array inside the 2D array represents a different row. So this is row 1. You see 5 3 dot dot 7 dot dot dot. So remember, the dots are the empty cells. 5 3 dot dot 7 dot 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 all the way up. Then this would be row 2, right? Boom. That's this row right here. This is the third row right here. This is the fourth row right here, and so on and so on, all the way to the bottom of the grid. Now our output is this. This would be the same grid, but it's going to follow the same rules, the requirements that they give us, right? So as you can see, this row, excuse me, y'all, this row contains numbers 1 through 9. This row contains numbers 1 through 9. This row contains numbers 1 through 9. Well, let me go ahead and copy and paste this, y'all, so y'all can see the columns as well and see how it's supposed to look when it's all said and done. Oh, I didn't expect them to do it like that, though. I thought they were going to line it up for us. But since they didn't, it's no big deal. We could line it up ourselves. Boom. So let's just go ahead and do that. Just a moment, y'all, so we can have our full grid and we can see what the final grid would look like. Let's just delete this this 2D array for a second. Boom. So as you can see, this represents the grid that we have. Uh, this represents this grid just after it's been filled in. So as you can see, this row, the first row, now has numbers 1 through 9. The second row now has numbers 1 through 9. All the way down to the bottom has numbers 1 through 9. Then similar for each column. Each column has all of the numbers 1 through 9. Boom. Each column as we go all the way, all of them. And then each grid, 3 by 3 grid. So this grid right here will have all of the numbers 1 through 9 as well. Come right here, it's a new grid. This grid right here will have all of the numbers 1 through 9 as well. And then this grid right here will have all of the numbers 1 through 9 as well. And then we can do that as the same thing for the whole square grid. And that's our output. So explanation says the input board is shown above and the only valid solution is shown below. So as you can see, this solution is just going to match this output grid right here, right? Where each row, once again, corresponds to each array, and then the columns will match up as well. So boom, that's how Sudoku works. If you've ever played it, then I'm sure you understand what we're trying to do. If you haven't played it, I suggest you go play it. It's actually a fun game that gets you thinking, gets the mind moving. It's like a puzzle type of game. So yeah, get some practice in with your critical thinking skills and math skills. Now, now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we are going to do for our solution, we're going to create a helper function. So the helper function is going to be outside of the main function. We could call this function solve. So we'll just say, sorry, y'all, that should be lowercase, private func. We call it solve. We'll open up the parentheses. We're going to say underscore board colon. It's going to be in out to the array of characters. So boom, two square brackets. Then we pass in character. Come outside those square brackets. We're going to say underscore rows colon. That's going to be in out an array of integers. Then we're going to say underscore calls for columns. That's going to be then we'll say colon. Sorry, put an L after this. We can put an S after the L and the S after the rows. We call it rows and calls. Then we're going to open up the brackets. That's going to be an array of integers. Come outside of that, we're going to say comma. Then we're going to say underscore boxes colon, and that is going to be an array of integers as well. Then the function is going to return a boolean, just like that. Boom. Then we can open up the brackets and let's get this party started, y'all. So first we're going to loop through every cell in the board. So we're going to say for I in 0 dot dot up to less than 9, open up the brackets. Then we're going to say for j in 0 dot dot less than sign 9. Then we're going to say where board square bracket I, come outside of that, square bracket j, come outside of that. We're going to say equal equals, open up the quotation marks, put the period, and this is going to find the empty cells. We're going to come outside of that and open up the brackets. Then we're going to say let box index equal, open up the parentheses, I divided by 3. Come outside of the parentheses, we're going to say times 3 plus j divided by 3. Sorry, that should be divided by y'all. Boom. Then we'll come underneath that, we're going to say let use numbers. We're going to set that equal to rows square bracket I. Then we're going to say one vertical line calls square bracket j, so that one vertical line is the bitwise OR. Do that again. Then we're going to say boxes square bracket box index. Boom. Now we're going to combine our bit mask for current row, column, and box. So we're going to try all possible numbers 1 through 9. So we're going to come underneath this. We're going to say for num in 1 dot 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 9, open up the brackets. And we're going to create a bit mask for the current number. So we're going to say let mask equal 1. Then we're going to shift 2 of these signs, 2 less than signs, open up the parentheses, num minus 1. Boom. Then we're going to say, come underneath this, and we're going to say, if, open up the parentheses, if used numbers, and, bitwise and, mask, so 1 and sign, mask, equal 0, then we're going to open up the brackets. Boom. And the number is not yet used in this row, column, or box. We're going to place the number tentatively. So we are going to come right here inside this if, and we are going to say board, square bracket I, square bracket J, equals. So I come outside the square brackets, say equals, character, open up the parentheses. We're going to use some string interpolation. So we'll open up the quotation marks, slash, open up the parentheses, num, close the parentheses. Boom. Come underneath this, we're going to say rows, square bracket I. Sorry, y'all. Rows, square bracket I. We're going to say vertical line equals mask. Then we're going to do the same thing for calls, square bracket J. And we're going to, sorry, y'all. Square bracket J. And we're going to say, sorry, y'all. Bitwise or equal to mask. Come underneath that. And we are going to say boxes, square bracket, box, index. Come outside of that, vertical line equals mask. Then we're going to recursively continue solving. So we're going to come underneath this and we're going to say if solve, open up the parentheses. We're going to say and board, comma, and rows, comma, and calls, comma, and boxes. Boom. We're going to come right here. We have to put this and sign first because these are in and out functions. So then we're going to open up the brackets. We're going to come right here. We're going to return true if solved. So we're going to propagate the success upwards. Then we're going to backtrack and undo the placement by coming right here underneath this if, and we're going to say board, square bracket I, square bracket J. Now we're going to set that equal to, open up the quotation marks, put the period, come underneath that. We're going to say rows, square bracket I, and equals, put this little wiggly line, mask. So what this line right here does is, or the tilde line is the bitwise not operation. This is the bitwise, this line right here is the bitwise not operator. And all it does is it's going to invert every bit in a number. So it's going to turn all the ones to zeros, and it's going to turn all the zeros to ones. Boom. So, but we're not done yet because we still have to do the calls. Just wanted to explain that to y'all real quick. So we're going to say calls, square bracket J, come outside, same thing, and equal sign. Do the same thing, the tilde or the little squiggly line, we're going to say mask. Then we are going to do the same thing for the boxes and box index by saying boxes, square bracket, box index. Sorry, y'all, just realized that should be an X, box index, and do the same thing. We're going to say and equal sign, little squiggly line, mask. Boom. Then if no valid number can be placed in this cell, then we're going to backtrack by coming right here and we say return false. Boom. Then if no empty cell remains, then and the puzzle is solved, we'll come right here and we can say return true. Boom. But we're not done yet because we still need to get into the main function. So in this main function, each row, column, and 3x3 box will be tracked using a bit mask. For example, if 5 is placed, then the 5th bit will be set to 1. So we're going to come right here, and we are going to say, declare a variable called rows, set that equal to an array, open up the parentheses, it's going to be repeating, colon 0, comma, count, colon 9. Then we're going to do the same thing for calls. So we really could just copy and paste this part right here. And we're going to, or we could copy and paste the whole thing really. Boom, just copy and paste that. And we are just going to change this rows to calls. Because these are just default values, right? It's not going to stay the same. So we just need to create all the default values, and then we do the same thing for the boxes. So we just say boxes. Boom. Then we're going to pre-fill the bit mask with numbers already present in the board, because as you can see, they'll give us some numbers, right? So we have to pre-fill the bit mask for that. So we're going to say for I in 0 dot dot less than sign 9, open up the brackets, for j in 0 dot dot less than sign 9, open up the brackets, and we're going to say if board square bracket I square bracket j does not equal exclamation point equals, open up the quotation marks period. So meaning if the board does not have a blank space in the cell, then we're going to open up the brackets, and we are going to say we're going to convert the character to the integer. So we're going to say let num equal int, open up the parentheses, string, open up the parentheses, board square bracket I square bracket j, and then we need to force unwrap it with the exclamation point. Then we're going to create a bit mask for this number. So we're going to say let mask equal 1 less than sign, open up the parentheses, nums or num minus 1. Boom, come underneath that, and we are going to calculate which 3x3 box the cell belongs to by saying let box index equal, open up the parentheses, I divided by 3, come outside of the parentheses, times 3 times j divided by 3. Boom. Now we're going to mark this number as used in this row, column, and box by coming underneath this. We're going to say rows square bracket I vertical line equals mask. Then we're going to do the same thing for calls. So calls square bracket, this time j though, calls square bracket j, vertical line equals, sorry y'all, it should be the vertical line or bitwise or mask. Boom. Do the same thing for boxes or box index, boxes square bracket box index, same thing, vertical line equals mask. And then we need to start our recursive backtracking solver by, we can just come right here and we are going to call solve, open up the parentheses, we're going to pass in and board, comma, and rows, comma, and calls, comma, and boxes. Sorry, y'all, should be no space in between the and. Boom. So that should be all she wrote, y'all. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Okay, so we have an error right here. So let's see. Oh, sorry, y'all. Call should be in out as well. So we have to put the in out right here. Sorry, y'all. Or they all should be in out. Calls should be in out, and boxes should be in out. Now that should do it. Now let's run it, see if that works. Cannot find rows. Sorry for the typo, y'all. Let's run it again. Cannot find boxes. Oh, sorry, y'all, for the typo. Let's run it again. Okay. JBoard should just be board. Let's run it again. It's a lot of typos, y'all. My bad. Moving too fast. Oh, that should return true. now let's try it. Okay, and then after all of that, still is not working. So let's see what happened here. Oh, sorry, y'all. This should be 3 plus J, not times J. Sorry about that. Boom, plus. So now let's run it, see if that does the trick. And it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Because we all know how LeetCode can be. It's not guaranteed. And look at that, y'all. 339 milliseconds beats 93.75% of users. That's what I'm talking about. Those are some good numbers right there. So before we leave, y'all, make sure you get one more look at the code. This is the top part of the code with the main function. This is the rest of the main function. Then this is our helper function. This is the top part of our helper function. And this is the rest of our helper function. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.